Hello everybody, I hope you can hear me. If you can hear me, can you give me a smiley face, please? Thank you very much. Are we all able to see the screen clearly? If you're not able to see, please let me know. Okay, you want the screen to be bigger. Does this work? I hope this works. Okay, perfect. Hello everybody. Good evening. I hope you are having a lovely evening. Those of you who are already in here, please try question 1 and type your answer in the chat. Don't forget to like, follow, and share this live for all your friends to learn together. I see that the screen is a little bit blurry. Let me work this out first. Okay. Okay, I think this works. Those of you who do not have this worksheet, you can look at our Telegram channel. The worksheet has been shared in the Telegram channel. For new joiners, good evening. My name is Coach Shahira. I will be bringing you through a set of revision questions involving fractions, okay? We will be learning about fractions, specifically remainder concept today. All right, I am going to begin in 1 minute. Again, those of you who are here, don't forget to like, follow our TikTok channel, and don't forget to share this live for all of your friends to learn together. Okay, I see that a lot of you have already started. Thank you for sharing. Those of you who shared that you've already liked and followed us, thank you very much. Let's begin, all right? Okay, question number 1. Let's run through question number 1. Evelyn gave 1/4 of a cake to her friend and cut the remainder equally into 4 slices. What fraction of the cake was each slice? All right, so we want to look at this as rather we want to focus on the remainder first. Okay, the keywords in this question here are the remainder. What did she do to the remainder? She cut them equally into 4 slices. All right, so what we want to do here is to first go and look for what this remainder is. Okay, every single time the question says the remainder of the remainder of the remaining, anything that resembles these keywords, we want to look for the remainder first. Okay, I see that orange is not very clear on the screen for you guys, so let me change it to red. I hope you're able to see better. Okay, so the remainder in this case would be, since we are looking at a cake means 1 cake, therefore the remainder would be 1 minus 1/4. Okay, we take away 1/4 because she gave this to her friend. Yeah, so 1 minus 1/4, we will be left with 3/4. Okay, all right, so because she cut this equally into 4 slices, the keywords cut equally, okay, the keywords cut equally tell us to divide. Every time we see cut equally, share equally, pack equally, we always want to think of divide. All right, therefore each slice is going to be 3/4 divided by 4, because we cut them equally into 4 slices. Okay, so the fraction for each slice would be 3/4 divided by 4. Now, do we remember how to divide fractions? Okay, I see that most of you have typed in divide by 4. You are right. Okay, to divide fractions, all right, the first step, let me write this down. The first step that you want to do, okay, for fractions division, step 1, you want to make it look like something out of something, divide by something out of something. Okay, so you want it to look like this, to have this template. All right, so for it to have this template, we see that the first fraction already has this template. Okay, the divide is already there, and the second fraction is the one that we don't see yet. So to turn a whole number into a fraction, we can just write out of 1. So we are going to get 3 out of 4 divided by 4 out of 1. Okay, that is step 1. Step 2, we are going to use this method called KCF. Okay, keep, change, flip. Okay, I understand that some schools teach as KFC. Some of your school teachers teach you as KFC. Okay, that basically means the same thing. What we want to do here is to keep the first fraction, change the divide into a times, and then flip the second fraction. So basically we are looking for the reciprocal. Okay, when we flip, we are looking for the reciprocal, and that would be 1 out of 4. Okay, and then the next step is to do cross cancellation if possible. If there is nothing to cross cancel here, for instance, 3 and 4 cannot be further simplified. They cannot be divided by the same number again. Okay, to become a more simplified version. Similarly, 1 and 4 cannot be further simplified. Therefore, our final answer would be top times top, 3 times 1 to give us 3, out of bottom times bottom, 4 times 4 to give us 16. Therefore, the correct answer is option 4. Okay, the correct answer is option 4. Okay, I see that a lot of you are looking at KFC chicken here. That's maybe one way to remember KFC chicken. Okay, when you are doing fractions division, the first thing you want to do is to make sure you have this template. Okay, so if you have whole numbers, you got to change it first into an improper fraction. Okay, and then what you want to do next is to do keep, change, flip. You keep the first fraction, change the sign into a multiply, and then you flip the second fraction. Okay, that way you can continue doing fractions multiplication, a very simple cross cancellation if possible. If not, you just multiply throughout. You will get 3 out of 16 as your final answer. Okay, those of you who got correct, well done. Alright, for new joiners, again, my name is Coach Shahira. We are doing fractions, mainly remainder concept today. So those of you who have just joined, if you do not have the worksheet, you can just write this on a foolscap paper. For those of you who want the worksheet, it's retrievable. You can get it on our Telegram channels, yeah? Alright, let's move on to question number 2. Okay? Don't forget to like, subscribe, follow our TikTok channel. Okay, you can follow all our socials. And please also share this live with your friends so that we can all learn together. Alright? Okay. Great. Let's move on. Question number 2. Okay, question 2. A box contains green, red and blue markers. 1/4 of the markers are green, 2/5 of the remaining markers are red, and the rest are blue. What fraction of the markers are blue? Okay. Alright. So for this question, again, we see the keywords of the remaining. Okay, when we see of the remaining, this signals our remainder concept. What I want to teach you right now is to actually use this method called the branching method. Okay, every single time you see of the remaining, let me write it down for you. When you see of the remaining, or when you see of the rest, or when you see of the remainder, okay, basically they all mean the same thing. What you want to think of is the branching method. Okay, the branching method is actually a very useful way for you to solve fractions involving the remainder concept. Alright? Okay, so I am going to give you some time to try this question. Okay, for those of you who don't know what the branching method is, no worries, you can also use the model method. Okay, try this question first using whatever methods that your school has taught you. Alright, and then I'll give you some time first before going through together. Okay, you can also discuss in the chat what you're going to do to solve this question. I see that some of you are saying to change to the same denominator. Okay, should we do that? Okay. I will go through the question in about a minute's time, yeah? Do you find this question difficult? How are we doing so far? All good? Okay. Let's run through this question now, yeah? Okay. Alright, so let me run through the branching method first. Okay, like I mentioned, whenever we see of the remaining, we want to use branching method to help us solve the question. So how do we use the branching method? We will start off with a total. Alright, we have the total markers. Okay, so that's what we are going to do first. Then we will branch out to what the question told us. The question told us that 1/4 of the markers are green. So in fractions, the denominator always refers to the item after the word of. So our keyword of here tells us that 1/4 is of the markers. So it's of the total. Therefore, I am going to branch out to the green markers. Okay, this is 1/4. Alright. Then I am going to branch this out, okay, to the complement of this fraction. Okay, what does that mean? I am going to look for what is this remainder first. Okay, why am I looking for this remainder first? Because the next line says it's 1/4 of the remaining, which tells us that it is not of the total. Okay, we have different bases here. This is of the total markers, whereas 2/5 is of the remaining. So we got to look for the remainder first, yeah? So this remainder is basically 1 minus 1/4 to give us 3/4. Okay? Then from here, we can branch out to red markers. The red markers are 2/5 of the remaining. Okay, 2/5 of the remaining, and the rest are blue. Therefore, the next branch that I am going to draw is for the blue markers, and they would be 3/5 of the remaining. Do we all understand why it is 3/5 here? Okay, yes, this is also applicable for P5 students. So if you are a P5, you can stay tuned. We can watch and learn together, yeah? Okay, so again, this is 3/5 because it's 1 whole minus 2/5 to give us 3/5, yeah? Okay, so the next thing we want to do in branching method is to link everything below back to the total. And how we do that is to multiply everything in its path. Okay, so we multiply everything in its path. These branches here basically tell us of. So we see 2/5 of 3/4, which is the remainder. And of, we have learnt last week that of means multiply. So I am going to multiply by the remainder, which is 3/4. Okay? And this will give me, what I can do here is to cross cancel, divide 2 by 2, divide 4 by 2. Okay, and I am going to get 3 out of 5. I'm sorry, 3 out of 10. Okay, I'm going to get 3 out of 10 here. Similarly, we can do the same for blue markers. That is going to be 3/5 of 3/4. Okay, so we multiply by 3/4 as well. Okay, this time round we cannot cross cancel anything. Therefore, our final answer would be 9 out of 20. 3 times 3 is 9. 5 times 4 is 20. Okay? Therefore, my final answer for blue would be 9 out of 20. Option number 4. Okay? All good? Alright, let's have a little discussion in the chat box, okay? Alright, let's have a little discussion in the chat box. Why do you think, let me write down the question for you, why we cannot make denominators for 1/4 and 2/5 the same? Why do you think so? Okay, Can you type your answers in the chat? Why do you think we cannot make the denominators for 1/4 and 2/5 the same? Okay? Some of you is saying different families. Some of you forgot. No problem. We will talk about this in a short while. Okay. Anybody else? Cannot make the same answer. Can you be a little bit more specific? What do you mean by that? Okay. Somebody gave the correct answer. Different families. So we are looking at different bases. That is indeed correct. Okay. Yes, somebody else gave the correct answer as well. 2/5 is of the remaining, not of the total. Indeed. Okay. So those of you who do not know, let me explain, yeah? Thank you for chatting, typing your answers in the chat box. Let me explain. 1/4 here is of the total. Okay? Of the markers means of the total. Whereas 2/5 is of the remaining. Total and remaining are not the same. Okay? Total and remaining are not equal. Therefore, we cannot make the denominators the same. Do we understand now? Okay? Do we all understand? Yes? Okay? Those of you who don't understand, one more time. The question says 1/4 of the markers. Okay, 1/4 of the markers, which means we are looking at of the total. The markers just means all of the markers, which means the total. Yeah? And 2/5 is of the remaining. This remaining is after you take out the green markers. Okay? This one, let me show you one more time. This one is green plus red plus blue, everything. Whereas this remaining here is just blue and red together without the green. Because green is already 1/4. Clear? Okay, does this make more sense now? I hope it does. Alright, fantastic. Okay, so let me give you an overview of this entire page here. Okay, for those of you who just joined, my name is Coach Shahira. We are going through fractions remainder concept. I hope we are all learning together. Okay, please take a moment to help me spam the like button, everybody. Okay, share and follow our channels. Alright, can we all spam the like button? Thank you very much. Alright, okay. Shall we go on now? Alright, thank you. Many of you are saying slay, slay, slay. Okay, I hope you are slaying your math results too. Let's move on. Question 3. Okay. Question 3. Theo spent 7 out of 12 of his salary and gave 7 out of 15 of the remainder to his wife. He then donated 1/4 of what was left to charity and saved the rest. If he saved $600, how much was his salary? Okay? So somebody is asking, is this similar to what we just see earlier? If you think this is similar, what do you think, or why do you think this is similar? Okay, why do you think this is similar? Those of you who just joined, please take a second to read this question. Okay, and those of you who are already trying, can you please type into the chat, what do you think is the key word or are the key words to this question? Okay, Fazrin, you are right. Okay, what do you think are the keywords to this question? Some of you have gotten it right. Okay, the keywords, you have typed it correctly into the chat. Very good. Okay, so those of you who identified the keywords to be of the remainder, well done. The next step is to identify, when we see of the remainder, what do we do? Okay, what do we do? Do you all recall? Whenever we see of the remainder, a switch must turn on in your brain to tell you, I must always use what method? Of the remainder means we use, okay, some of you have gotten it right. Yes, indeed, we use branching method. Fantastic. Okay, branching method indeed. Great. So, can you try the branch on your own now? Okay, try the branch on your own now. I'll give you about 2 minutes. We will continue at 8:28 p.m. Okay, it's now 8:26 p.m. We will continue at 8:28 p.m. I want all of you to try the branching method now. How are you going to branch this question? Okay, let me give you a clue. We always start with the total. Yeah? Okay. Somebody is asking if there's a high chance of this question coming out in exams. This is actually a very common question. Similar questions have appeared in PSLE before, and there are also very similar questions that appear in Primary 5 as well as Primary 6 school examinations. So yes, this is quite common. Okay, we are at question 3. We have 2 more questions after question 3. So those of you who need to leave, I will end maximum by 9 p.m. Okay? One last minute for you to try. What is the estimated number of questions there is for this type? Well, in the PSLE, fractions can maybe appear once in this type of long question. It can maybe appear once or twice in paper 2, and it can also appear once or twice in paper 1. Okay? Sometimes questions like this can also appear in paper 2 where you have both fractions and percentage, or maybe even ratio, okay, together in one question. Yeah? Okay, it's 8:28. Let's run through. So from this total, I am going to branch out to whatever they told us that he did with his salary. Okay, so the first keyword is of his salary. Therefore, he actually spent 7 out of 12, which we are going to write down first. Okay, 7 out of 12. Then in the next fraction, they already gave us of the remainder. It is no longer of his salary. Therefore, we need to look for this remainder first. Yeah. So the next branch is going to be the remainder. Okay, and the remainder is going to be 5 out of 12. Notice every single layer is 1 whole. Okay, in the previous question as well, every single layer is 1 whole, yeah? Okay, then from this remainder, he gave 7 out of 15 to his wife. Okay, he then donated 1/4 of what was left. Again, what was left is not the same as this remainder. What was left is after he gave to his wife. So we must go and look for what was left first. Okay, oops. So let's call this the rest, whatever that was left. It's going to be 8 out of 15. Again, every single layer must add up to 1 whole. Then, after he gave 1/4 of what was left, he saved the rest. Okay, so after he gave 1/4 of what was left to charity, so let's write down charity first. 1/4. Then he saved the rest. Okay, whatever that remains, he's going to save them, and it's going to be 3/4. So this is a 3-layer branch. Okay, again, each layer must add up to 1 whole. Alright? Do you remember what we should do here after we have drawn out the branch? Do you remember? Okay, after we have drawn out the branch, we must relate everything back to the total. So all these far away fractions, we must bring it back up to the total. And how we do that is to multiply everything in its way. Yeah? So the first thing that we can do is to look at the wife. The wife is of the remainder. Okay, whatever he gave his wife. Let me slow down. Okay, thank you. Whatever he gave his wife is of the remainder. Okay, therefore we are going to multiply. Recall, we need to multiply everything that we see above so that we can relate it back to the total. Okay, so we are going to multiply 5 out of 12. That's right, we have to relate back to the total. Okay? Alright, then from here, again, cross cancellation. Please try that on your own. Okay? Cross cancellation. We can cancel 5 to become 1. Cancel 15 to become 3. What I'm doing is dividing by 5. Okay? 5 divided by 5 is 1. 15 divided by 5 is 3. Alright? This will give us 7 out of 12 times 3, 36. Okay? Some of you are very helpful in the chat, explaining to your friends. Indeed, why we multiply 5 out of 12 here is because he gave 7 over 15 of, recall of means times, the remainder. Okay, remainder is 5 out of 12. Okay, so we are going to get 7 out of 36. We can do the same to the other side. Okay, we can do the same to the other side. 8 out of 15, we also multiply by 5 out of 12 because this is 8 out of 15 of the remainder. Okay, so multiply by 5 out of 12. This time round, we have 2 sets of numbers that we can cross cancel. Okay, so 5 becomes 1, 15 becomes 3. 5 divided by 5 is 1, 15 divided by 5 is 3. Okay, and then 8 divided by 4 is 2, 12 divided by 4 is 3. Okay, so we will get 2 out of 9. 2 out of 9. Yeah? Okay, so for 3 and 12, we cannot cross cancel 3 and 12. Okay, like the name suggests, it's cross cancellation. We can only cancel across. We cannot cancel side by side. Yeah, because they are both in the denominator. Okay, when we cancel, we are actually simplifying. Okay, when we cancel, we simplify. Clear? Alright, then we can do the same to 1/4 and 3/4. Okay, after we multiply, this is already of the total. So the next step, yeah, the next step is to multiply 1/4 to 2 out of 9. Okay, multiply it with 2 out of 9. Multiply 3/4 with 2 out of 9 so that we can relate it to the total as well. Okay, so this is a very long question. I hope you are staying with me. Okay, this is a very long question and it appears a lot in school exams. So please stay with me. Okay, so 1/4 we multiply by 2 out of 9 because again we want to relate it to the total. So we multiply by what we see above. Okay? We are going to get 2 cancel becomes 1. 4 cancel becomes 2. Okay? Divide both by 2. This gives us 1 out of 18. And on the other side, 3/4 times 2 out of 9. 2 again, divide by 2 is 1. 4 divide by 2 is 2. 3 divide by 3 is 1. 9 divide by 3 is 3. We will get 1 out of 6. Okay, so far so good. Okay, let me pause here for a short while. Everybody okay? Alright. Okay. So what are we doing here and why are we going through all this trouble? This is so that we can relate to the total. Then we can use units to solve. Okay? Okay, so that we can use units to solve by relating everything to the total first. Okay? So what we can do here is, we know that the total, 12 units, but there's also 36 and 9. They all refer to the same total. Okay, and we see 18 and 6. So the next step is to make all these numbers the same. 12, 36, 9, and 18. We can make all of these numbers the same, which is to turn it into 36. Okay, same denominator because everything is of the total. Okay, so to get the numerator here, we multiply by 3 to give us 21. Okay, similarly on the other side, multiply by 3, we will get 15. 7 out of 36 is already there. 2 out of 9 is the same as times 4 times 4, we will get 8 out of 36. Okay, and 1 out of 18 is the same as times 2 times 2, 2 out of 36. And 1 out of 6 is the same as 6 out of 36. Okay, so what we can do here is, we know that the total is going to be 36 units, so we can write units all over. Total is 36 units, all my denominators. He spent 21 units. Okay, the numerator here 21. He spent 21 units. Okay, then the remainder is 15 units. Okay, wife is 7 units. The rest here would be 8 units, just looking at numerators. Okay, charity 2 units, and saved would be 6 units. Okay, then now we can relate to units, the units to the numbers. So now I know that 6 units is $600. So saved equals 6 units equals $600. 1 unit would be $100. And finally, his salary, the total, which is 36 units. 36 units would be $3,600, which is 3,600. Okay, so my correct answer is option 3. Okay, option number 3 is the correct answer. Alright, so this question, how long will it take, or rather how long you should spend on this question? Typically, this question is roughly about 4 marks. So if you were to multiply, if it appears in paper 2, okay, you can spend about 5 minutes. Okay, if it is 5-mark question, then you can spend about 6 minutes. Okay, 4.8 minutes, roughly 5 minutes there. Or if it's a 5-mark question, then you can spend about 6 minutes on it, yeah? Okay? In the exams, please remember whatever you have written down, try not to erase first, okay? Try not to erase until you have found the correct answer and your previous method is wrong. Then you can solve, okay? Otherwise, in the exam, if you did not manage to solve and you erase whatever you have thought of, you cannot even get any method marks, yeah? Okay? This question is roughly around 4 marks, okay? Sometimes schools may give 5 marks to this question, okay? What happens if you spend more than 6 minutes on this question? Well, you will have less time for the rest of the questions. So it would be good if you can manage your time wisely, okay? Now, what I want to talk about is basically the other method, okay? I see a lot of you typing. What is the other method that you can use? Okay, and indeed, some of you have mentioned we can actually use model method. We can use model method, but ask yourself, class, okay, all of you ask yourself, 36 units. Imagine how long you must draw 36 units. Oh my goodness. Can you imagine your model will look super duper long and you have to make sure your counting is accurate. Okay, 36 units. Are you able to draw all of them? If you think it's very long and tedious, you can use fractions this way. Okay, if you prefer drawing and you are very sure that you will not draw wrongly or count wrongly, then go ahead, model method is fine as well. Okay? Paper 2, usually this question is in paper 2, yeah? Alright, let's take a short break. Okay, just take a short pause here. Please help me like this live. Okay, please help me like this live. Okay, can you help me like this live, please? Thank you very much. Those of you who are sharing the live, thank you very much. Those of you who have just joined, my name is Coach Shahira. My name is Coach Shahira, and we are going through fractions remainder concept. Okay? Thank you very much for all your likes. Those of you spamming, thank you very much. We truly appreciate it. Okay, 5, 4, 3, 2, and 1. Okay, you can like by double tapping the screen. Okay, all right, let's take a look at question number 4 now. Question number 4. Okay, the next question, I'm going to read it out for you in case those of you without the worksheets, you can't really see the question. Let me read it out for you. Anne baked some croissants for sale. After selling 48 of them in the morning and 3 out of 8 of the remainder in the afternoon, she had 25% of the croissants left. How many croissants did she sell in total? You see this question. We have both fractions and percentage inside, right? Just like I mentioned earlier. Okay, just like I mentioned earlier. We can actually, or rather schools can actually test you with a combination of fractions, ratio, percentage, everything in one question, okay? Which is what we have, what we have here, yeah? So again, we see that there is the idea of this keyword here, of the remainder, okay? Of the remainder. So when we see of the remainder like this, same thing, let's draw the branch, okay? We are again going to use the branching method. Okay? So for our branching method, we already know how to branch out using fractions, but we see a percentage here. So let's convert 25% into a fraction. Okay? We will get 25 out of 100, which is the same as 1/4, yeah? Okay, so let's take a look at this question. The branch is slightly different, so let me dive straight into the question with you. Okay, we are going to have a total. We don't know how much is this total, no problem. What she did was to sell 48 of them in the morning. Okay, she sold 48 in the morning. Now, why is this branching a little bit different? It's because we have a number inside our branch. Earlier on, all our branches were fractions, okay? All our branches were fractions. Okay? Next, we see of the remainder. So we are going to again write down the remainder. Okay, we are again going to write down the remainder. We don't know how much is this remainder, okay, because we cannot find one whole here because this is a number. If this is a number, we can leave the remainder as it is for now, okay. And from this remainder, we have in the afternoon 3 out of 8. Therefore, whatever that's left would be 5 out of 8. Recall, each layer is 1 whole. Okay? That's why left is 5 out of 8. But the question says left is actually 1/4 of the total. 1/4 of the total. Therefore, okay, therefore we see fraction of remainder equals to another fraction of total. Okay, so another learning point here. Okay, another learning point here. Whenever we see fraction of remainder equals to fraction of total, what we want to think of is the equal concept, specifically equating numerators. Okay, whenever we have fraction of remainder equals to another fraction of total, we want to equate the numerators. Is everybody able to see? I hope you can see better now. There we go. Okay, is this better? Alright, so we want to equate the numerators. Okay, whatever that is left, we know that whatever that is left is 5 out of 8 of the remainder, and it is also 1/4 of the total, which the question told us. Okay, again, same as question 2. We don't equate denominator because they are referring to different things. Okay, different things. We equate the numerators instead. Okay, so we make the 5 and the 1 the same. So we are going to get 5 out of 8 of the remainder equals to 5 out of 20 of the total. Okay? Equals to 5 out of 20 of the total. Okay? Is everybody able to see? I hope so. Alright, so this tells us that the remainder has 8 units, the total has 20 units. So again, we can use units to help us. Okay, total is 20 units, remainder is 8 units. Okay, and left is 5 units, and afternoon, whatever that was sold is 3 units. So to get the morning, whatever that's sold in the morning, let me bring this down. Whatever that's sold in the morning is going to be 20 units the total, minus away 8 units the remainder. We will get 12 units. So far so good. Where I get the 20 from? Okay, so the 20 is actually from here, 1 times 5, because we want to equate numerators, okay, on the right hand side, and 4 times 5. Okay, this is where we get the 20 from, by equating numerators. Okay, we equate numerators. Okay, alright, so then 20 is the total units, remainder is 8 units because of the denominators here. 8 represents remainder, 20 represents total, so morning must be 12 units. Okay, morning must be 12 units. 20 units minus 8 units. So now I know 12 units is 48. 1 unit would be 48 divided by 12 to give us 4. Okay? 48 divided by 12 to give us 4. So 1 unit is 4. How many croissants did she sell in total? So total sold would be morning and afternoon. So that would be 12 units plus 3 units to give us 15 units. Okay, so 15 units would be 15 times 4 to give us an answer 60. Okay, so our final answer is number 4. Alright. Okay. This is another form of mixture, okay? This question has a mixture of branching as well as equating numerators. Okay, so 2 concepts here. I hope you remember how to solve question 4. Very, very common as well. Okay, so let me explain one more time. We have a total. Okay, we don't know how much is this total, no problem. We can branch it out to whatever that was sold in the morning, 48. Okay, 48 was sold in the morning and we don't know this remainder, no problem as well. From this remainder, 3 out of 8 of the remainder was sold in the afternoon. That means whatever that's left must be 5 out of 8. Okay, 1 whole minus 3 out of 8 to give us 5 out of 8. And the question says, hey, this 5 out of 8 of the remainder is the same as 25% of the croissants, which is of the total. Okay, of the croissants means of the total. That's why we equate numerators. We make the numerators the same. Okay? So we make the numerators the same already. My remainder now becomes 8 units. My total is 20 units. So 20 units you branch out to 8 units. The other side must be 12. Okay, the other side must be 12 units. Because 12 and 8 make 20. And that's how I use 12 units is 48 to find out total sold, which is 12 and 3 to give us 15 units. Okay? All good? Okay, where the 3 units come from? The 3 units is from the afternoon. Okay, why is it 3 units? It's because the remainder is 8 units, left is 5 out of 8, which is 5 units. Okay, do we understand? Okay, do we understand now? Alright, I hope we understand this a little bit better. Okay, those of you who want the solutions, you can request the solutions, okay, so that you can revise it again. Okay, after this live, I will make the solutions available for you guys as well, yeah? Okay, so that you can revise it again. Alright, we have 6 more minutes. Let's run through the last question. Okay, let's run through the last question. Okay, before we go on to the last question, can you help me like this live? Okay, we make the numerators the same because part of the remainder, which is left, is the same part of the total, which is also left. As long as they are talking about same parts, okay, we make numerators the same. When they tell you that the parts are the same, which refers to left, whatever croissants that's left, they are the same. Therefore, you make numerators the same. If they tell you same totals, then you make denominators the same, okay? Alright, let's move on. Thank you everybody for liking and sharing. Let's move on to the last question. Okay. This last question is slightly different. We will use a different method, okay? Recall, I mentioned of the remaining. That means we use branching method. But this question, let's see what we have here, okay? 𝐿𝐼 spent 4 out of 7 of her money on 18 pence. She used the remaining amount of money to buy 10 pens and 4 files. If one file was given free for every 6 files, how many files can she get if she used all her money to buy files? Alright, for this question, if she used all her money to buy files, how many files can she get? Do we see of the remaining? Do we see of the remaining, guys? Not quite, right? We don't see of the remaining. We only see the remaining. We don't see of the remaining. So if we don't see of the remaining, we can no need to use branching method, okay? Which is not what we are going to use here. Okay, we don't see of the remaining, so we don't need to care about branching method for now, yeah? So we don't use branching method here. So let's take a look. We have pens plus files. Very confusing. So let's see, okay? What we are going to do here is, I am interested in files. So I'm going to convert all the pens into files. Okay? I am interested in files, so I only want to look for files. Okay? I don't want pens. So if I don't want pens, I want to know how much is one pen so that I can replace all of these pens. Okay, which is what we are going to do here. We know that 18 pens is 4 out of 7 of her money. Okay? Alright. Then that means one pen would be, what do we do here? From 18 to find 1, we divide. So again, we see fractions division. Okay? So 4 out of 7 divide by 18 here. Everybody understand? 4 out of 7 divide by 18 here. Okay? So same thing. Step 1, make them having this template. Something out of something, divide by something out of something. Okay? Just like what we see in question number 1. Okay? Then step 2, KCF, we keep the first guy, change the sign, flip the second guy. Okay, this is KCF. Just like what we went through in question 1. Okay? Then we can do cross cancellation. 4 divided by 2 is 2, 18 divided by 2 is 9. We will get 2 out of 9 times 7, 63. Okay, KCF is keep, change, flip. Keep the first fraction, change the sign to multiply, flip the second fraction. Okay? Now somebody mentioned we can change the files to pens as well. No problem, but that's a longer method because over here we are looking at files. So if we change the files into pens, we will have pens everywhere. But we don't want pens, we only want files. Okay, so we do the other way around. Okay, this method is not exactly assumption, not quite. We are looking at fractions here. Okay, so one pen is 2 out of 63. Now what I'm interested in is to look at the line that has files. So I have files here. Therefore, I need to look at everything here. I have 10 pens, 18 pens. So that means all of my money. Okay, she spent on 18 plus 10, 28 pence. Why 28 pence? Because 18 pence plus 10 pence. Okay, so 28 pence is going to be 2 out of 63 for 1 pen times 28 out of 1. Okay? Okay, so to find 28, we multiply by 28. 63 can be divided by 7 to give us 9. 28 can be divided by 7 to give us 4. So this tells us that she spent 8 out of 9 of her money on 28 pence. Okay? So, how does this help us? Let me write it down for you, yeah? So, all of her money, she spent on 18 pence, plus 10 pence, plus 4 files, right? Which is the same as 28 pence, plus 4 files. And we know that 28 pence is 8 out of 9 of her money. Therefore, 4 files must be 1 out of 9 of her money. Can we follow? Okay, can everybody understand here? We found 28 pence, which is how many pence she bought all together. Okay, and all together she spent 8 out of 9 of her money. But she spent all of her money. Okay, she spent 4 over 7 and the remaining 3 over 7. So all of her money she spent on 4 files and 28 pence. So the 4 files must be 1 out of 9 of her money. Okay, so if 4 files is 1 out of 9 of her money, that means all her money, which is 9 out of 9, must be 4 times 9 to give us 36 files. Can follow so far? Okay, can follow so far? 1 out of 9 of her money was spent on 4 files. So all the money, 9 out of 9, must be 36 files times 9 here. Okay? Then from here, we can use sets method. For every 6 files, you get 1 free. So if I have 36 files, I am going to get 6 free. Right? 6 files, 1 free. 36 files, I will get 6 free times 6. Right? So in total, I will have 36 plus 6 to give me 42 files. So she can buy 42 files for with all of her money, which is option number 1. Okay? Can we understand? Are we all clear here? How many of you need me to repeat one more time? Anybody don't understand anything? Let me repeat one more time, yeah? Let me repeat. So, at first, we are told that she spent 4 out of 7 of her money on 18 pence and the remaining on 10 pence and 4 files. So, all of her money is 28 pence and 4 files. Okay, all of her money is 28 pence and 4 files. We know that 18 pence is 4 out of 7. So 1 pen must be 4 out of 7 divided by 18 to give us 2 out of 63. So 1 pen is 2 out of 63 of her money. So all the pens is 8 out of 9 of her money. That means the 4 files must be the rest of the money 1 out of 9. Okay? So if 4 files is 1 out of 9, all the money would be 36 files multiplied by 9 throughout. Okay, times 9 times 9. Okay, so that we have 9 out of 9. Alright, then for every 6 files, you get 1 free. So if I have 36 files, all my money I can buy 36 files, I will get 6 free files multiplied by 6. Okay, so with these 6 free files, the total would be 36 plus 6 to give us 42. Alright. Okay. So let me explain one more time. I see everybody so busy liking. Thank you very much for spamming. I hope you are listening as well. So let me recap what we have done so far, okay? So we have learned about fractions division, okay, using KCF, keep, change, flip. We have learned about branching method when we see of the remaining of the remainder, of the rest, we use branching method. Okay, we remembered that every branch, okay, or rather each layer of the branch must be one whole, okay? And then we have to do fractions multiplication to relate to the total. Then we can use units to solve, okay? Then afterwards, we also looked a little bit at how to equate numerators. When we see fractions of remainder equal fractions of total, we equate the numerator, okay? And in this last question here, we saw what if I see the remaining but not of the remaining. So if I don't see of the remaining, I don't need to use branching method. I can just find out, okay? If I want to find all files, I can just change all the pen. Change all the pen, get rid of all the pen, which is 8 out of 9 of the money, to help me isolate or find 4 files, which is 1 out of 9 of the money. Okay, and then we work our way there. Alright. Okay, I am so sorry for taking so much of your time, which is a little bit overshot, okay, a bit past 9 p.m, but I hope everybody learned quite a bit today. I enjoyed chatting with some of you on the chat box, and I hope we have a good time next week as well, okay? Same time next week. See you guys. Thank you, everybody. Bye-bye. Thank you. I'm going to end the live in 3, 2, 1. Thank you.